All right, let's look at the homework 11.3, problem number 6. All right, let's solve this first order linear equation with initial condition. All right, so let's see. So in this case, let's see, we can identify P. P is 1 here. And then Q would be 8 e to the x. All right, so let's find the integrating factor. Right, so this is going to be u is equal to e to the, let's see, integral of 1, right, with respect to x. So you get e to the x, right? So then we just have to use the formula. So y is equal to 1 over e to the x, right? And then integral, we have 8, so I'm going to put 8 outside, e to the x times u, which is another e to the x, so it's going to be e to the 2x with respect to x. Right? So you have 8 over e to the x. Right? Antiderivative of e to the 2x is e to the 2x over 2 plus some constant c1. Right? Then if you distribute 8 over e to the x to both terms, last term and that term, you're going to end up getting, right? So let's see, e to the x and e to the 2x, so so e to the x cancel out, and you're going to get the 4 e to the x, and then plus we have c1, 8 times c1 over e to the x, right? So there's no point of using a complicated expression for a constant, so we're going to call that guy c. So we get, right, 4 e to the x plus c e to the negative x, right? So let's use the initial value condition. So y of 0 is equal to, so if you plug in 0, e to the 0 is 1, so you have a 4 plus c e to the 0 is going to be again c, and this is equal to 4, right? Which means that subtracting 4, c is actually 0. Right, so c happens to be 0 there, so we have simply y is equal to 4 e to the x. Right, so let's type it in. So y is equal to 4 e to the x. Alright, let's check the answer. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.